57, finding inverse trig functions. As you can see by the page numbers, this is going to be a long one. All right, and we're going to have to use some of that unit circle stuff that we talked about a couple weeks ago. All right, so the very first thing that we have to do here is what is the inverse of each of these following? So really what this is asking is we want to solve for this angle measurement. How do we get this angle measurement by itself? Normally we would say that we would just divide by sine, but you can't divide trig functions. So instead what we're going to do is we're going to get our angle measurement by itself, and we're going to go and move that sign over, but it's not dividing by sine, it is sine inverse. And that inverse will be written with a -1 there. Alright, so what is the inverse of this one? This would be our angle measurement equals sine inverse of A, which would mean we'd have the exact same thing here. Down here we'd move the cosine over by doing our angle measurement equals cosine inverse of A. And then for tangent, the exact same thing here. We'd move the tangent over and go with our angle measurement equals tangent inverse of A. Alright, so we're going to use those in just a little bit. Every single time when we use the inverse to when we're doing these trig functions, we're trying to find the angle measurement. We're trying to find the angle of one of the angles in the triangle, how many degrees it is. Alright, and that's what this one asks. Find each inverse trig function value that exists, give answers in radians and degrees. Alright, now one thing that you can do is you can type this directly in your calculator. Sine inverse square root of 3 over 2 would be, if you type that in, we would just get 60 degrees. Alright, when we take that and change it to radians, remember we have to multiply by pi over 180, which would give us the 60 and the 180 cancel down to pi over 3. Alright, when we go cosine inverse of -1/2, we can type that in the calculator, and we get, that says 120 degrees. Alright, which when we multiply that by pi over 180, we would get 2 pi over 3. The 60 would go into both the 120 and the 180. We'd have a 2 and a 3 left over. Alright, down here, find each of the following values. We have cosine inverse of sine of 30. Alright, so what we could do is we could type in sine of 30, and we would get 1/2 for that. So how this would look is we'd have cosine inverse of 0.5 So that's what it would look like. And then if we did cosine inverse of 0.5, we would end up with, just by typing that in, we would end up with 60 degrees. Alright, we could do the exact same thing for sine of tangent inverse of 1. Alright, we're just doing it in the opposite direction here. So we'd have to figure out what tangent inverse of 1 is, which is 45 degrees. And then sine of 45 degrees would be 0.707. Alright, so that would give us our answer for that. We can just type those in. There's nothing wrong with that at all. Alright, now describe all of the values of sine inverse of square root of 3 over 2. Alright, so square root of 3 over 2, we can draw a triangle on our unit circle here. Square root of 3 over 2 would mean maybe something like this, with a line drawing straight down. Alright, and what sine works with is it's working with the opposite side and the adjacent, or the hypotenuse. Alright, so this square root of 3, what we could do is we could put that as the opposite side here. So square root of 3 goes there, and then our 2 goes as our hypotenuse. All right, now when we have square root of 3 and we have a 2, that means our other side is going to be a 1 here. All right, so there's our 3 sides. What kind of triangle do we have? We have a 30, 60, 90 triangle. All right, and the one that matters here would be down here in the corner, and that one, opposite the square root of 3, would be an angle of 60 degrees down here. All right, now that is not the only one, but that is our first answer. So we've got an answer of 60 degrees. All right, 60 degrees. We can also find another one, all right, by this opposite side is a positive square root of 3. We can also bring it over into a different quadrant over here, where this side, our opposite side, would also be square root of 3. All right, so remember, sine is opposite over hypotenuse. So there's our opposite side of square root of 3. It's positive because it goes up. Our hypotenuse is 2, again, just like it was for the first triangle. And then our adjacent side, this time because we're going backwards, it'd be a negative 1 there. All right, but this would still be a reference angle of 60. Okay, the only difference would be is that it's in the second quadrant, so we have to go 180 minus 60 to get 120 degrees. All right, but this time it says describe all of the values of this. Now, 60 degrees starts at the positive x-axis. It goes up to the terminal side, which would give us 60. But if we went all the way around the circle, we would get back to the exact same part. So for this 60 degrees, what we can do to deal with all of those times that we go around the circle, well, there's 360 degrees in a circle. And so we could add 360 degrees times however many circles we want to go around. And I believe the book uses n for that number of times. It doesn't matter, it's just a variable. All right, so we've got 60 plus 360n, and that would be one of them. The other one would be 120 that we found, but also plus 360n. All right, and that would describe all of the values. It doesn't matter how many times we go around. If we went around a negative amount of times, we would just put in a negative 1. If you put in a negative 1 here, that would give you an angle measurement that would still end right here on this side. All right, so here's our values that would work, the equations that would work to get this square root of 3 over 2 for sine inverse. All right, our next one, describe all the values of cosine inverse of 1/2. Well, we can draw a triangle again. Okay, cosine is adjacent over hypotenuse. So we're looking up here somewhere. All right, because it's positive, we know our adjacent side is positive. All right, so we'll draw this triangle in here with a line straight down. We know that our adjacent side is a 1. And we know that our hypotenuse is a 2. So that means our opposite side, not that it matters much, but our opposite side would be square root of 3. All right. What angle measurement would that be? I mean, even though it's a different problem, the answer is still 60 degrees. Describe all of them. So plus 360n would be the first one. Then we have to find the other one. For cosine, we want to find the other quadrant where the adjacent side is a positive 1. Well, where that would go would be down into the fourth quadrant. All right, so we would be down here with this triangle. All right, and really the only things that change here, our adjacent side is still 1. Our hypotenuse is still 2, just like it was before, and that's why this works in this quadrant. Okay, the only thing that changes would be this time we went up a square root of 3 for this one in the first quadrant. This one down below would be a negative square root of 3. Okay, it doesn't change our answer at all. Okay, this reference angle is still 60 degrees, so 360 minus 300, or 360 minus 60 would give us 300 degrees. So that's the first part of our answer, plus 360n. And that would give us all of the values for cosine inverse of 1/2. One more, we could do the same thing for tangent inverse. This says negative square root of 3. Well, what we could do if we really felt like it, because most of the time we have fraction for this, negative square root of 3 is the same as negative square root of 3 over 1. Alright, so then there's our fraction. Alright, we have an opposite side of negative square root of 3, so that's when we go down. Our adjacent side would be a positive 1 here, so we could draw that triangle in. That would put us with negative square root of 3, so we're going down. Adjacent side is a positive 1, so we're over here in the 4th quadrant. So we draw this in with a line going straight back up to the x-axis. Alright, and then we type these in. So tangent is opposite, so this side over here would be a negative square root of 3. The one on top would be a 1. Alright, well, for tangent, it's opposite over adjacent. Okay, now, most of the time for sine and cosine, we said, well, that negative just needs to stay with the one side, so that would put it over here. But if we came over here and drew in this triangle, we'd have a negative square root of 3 for going down, but then here we'd also have a negative 1, so we'd have a negative divided by a negative, and that's not what this ratio is talking about here. Instead, what it's looking for tangent is if we came up above and then draw this line straight down, we would have this side not be negative square root of 3 anymore. It'd be a positive square root of 3. And you're going, we need a negative square root of 3. How are we going to deal with that? Well, we can, if we divide by, instead of a 1, if we divide by a negative 1, it would give us the same exact effect. Because what we want for an answer is we want negative square root of 3 when we go opposite over adjacent. Square root of 3 divided by negative 1 is still negative square root of 3. So then we find our reference angles. Okay. Once again, square root of 3 is on the opposite side. Opposite that is 60-degree angles. So our reference angle again is 60 degrees. Remember, that is 180 minus the 60 to get a 120 plus 360n. And then for the other one, we're down here with a reference angle of 60. So 360 minus 60 would be 300 plus 360n. There's our two answers for tangent. All right, now we do this stuff to solve all sorts of different problems. We do this a lot with trig. A lot of different real-life applications use this stuff. Here are a couple equations that we can solve. All right, now it says solve 2 cosine theta minus 1 equals 0. Well, we want to get this theta all by itself. So how we do that is, and I'm just going to highlight it really quick to make sure that, that we have it. All right, so we want to get that red thing all by itself. What we do first is we go and say, all right, I need to add the 1 over to the other side. So we've got 2 cosine of theta equals, we add the 1 over, and now equals 1. Then we're going to divide by 2, so we've got cosine theta equals 1/2. And then we got to move the cosine over to the other side like we did on the very first page. So not dividing by cosine, we would take cosine inverse of 1/2, or cosine inverse of a positive 1/2. All right, now this you could just type in your calculator. All right, cosine inverse of 1/2 would give you, apparently the answer of the day is 60 degrees, because that is all we're getting here. So one of the answers here would be 60 degrees. All right, if it doesn't say to put both answers down, You don't have to. You can just put one of them down. All right, down here, 3 tangent theta plus 3 equals 0. All right, we can, once again, we got to get this theta all by itself. So we can go 3 tangent theta equals negative 3. And then we would divide by 3. So tangent theta equals negative 1. And then you got to get theta by itself. So tangent inverse of negative 1. All right, and if you throw that in the calculator, we get an answer of what my calculator says is a negative 45 degrees. All right, there's a problem with that. That is not between 0 and 360 degrees. So this, even though we did everything right here, the calculator says this, that's not right. This doesn't work. So instead, what we have to do, what would be equivalent to our theta would be when we add 360 degrees to this 45, that would get us all the way around the circle to be able to figure this out. All right, and that would give us an angle measurement of 315 degrees. All right, and that would give us our correct answer for this. So there is another one. Like I said, sometimes they will ask you what that is, and if they do, then you have to solve for it. If not, then don't worry about it right now. Just get me one answer and we'll call it good. All right, last one down here. Square root of 3 tangent theta plus 3 equals 0. All right, so we got to get theta by itself again. So we have to first subtract the 3 over. So I am just going to quickly recopy this. Okay, move it down here below. Set it equal to negative 3. And then we're going to go and say tangent theta. We would have to divide by square root of 3 here. Negative 3 divided by our square root of 3. All right, now for that, and then just to finish it off, we would have to move our tangent over to the other side. So theta would equal tangent inverse of negative 3 divided by square root of 3. Okay, and if you type that in your calculator, you will get an answer for this. All right, so let me do that quick. Tangent inverse of negative 3. Negative 3 divided by square root of 3 would give us negative 60 degrees. All right, well, that is a problem first of all, because it says for all real numbers of radians. Well, it's 60 degrees, so what do we have to do? We have to take this 60 and multiply it by pi over 180. All right. I don't know why it's printing. All right, we'll try this. Pi divided by 180, which would give us, when we simplify that down, we would get pi over 3. But then it also says for all real numbers of radians. Okay, so that is kind of like when we go back here, describe all the values. All right, we added 360 degrees times the number of circles that we took to get all of them. This one, we would have to do pi over 3 plus, now how many radians are in a circle? How many radians are 2 pi are in one circle, and then if we multiply that by n, that, and then add it to our pi over 3, that would get us all the real number of radians for that. Okay, there's one of your answers for it. We're good to go. All right, down here, we do the exact same thing. Solve each equation to the nearest tenth. All right, so this time now we're going to have to use our calculator to do this. All right, so first off though, we got to get this solved for theta. So we've got to go sine theta equals, we got to divide that 8 over. So we've got 5 over 8 there. And then to get theta by itself, we move the sine over to the other side. All right, so then we can grab our calculator and type that in. Sine inverse of 5 over 8 would give us an answer of 38.68 degrees, which, as you can see our restrictions here, would be between 0 and 90, so that would be okay, that would work. All right, so there's our answer for that. Down here below, we have the exact same equation, except our restrictions have changed. They're between 90 and 180. All right, we only got this one. Okay, so this is where we have to think about putting it on the graph. All right, because we want the answer that's between 90 and 180. So if we were to graph this out, remember sine is opposite over hypotenuse. Our hypotenuse here would be 8. Our opposite side would be a positive 5. Well, if we came up here and drew in this triangle, this opposite side would be 5, hypotenuse is 8. That'd be one of the answers. That's the one we already found. We want to find the other one for sine, which would mean we would come up here and then draw our line straight down to make that triangle here. That would mean that our opposite side is 5 here. Our hypotenuse is 8. All right, we don't really care what the adjacent side is. We just want to find this angle here. Well, what we know for sure is we know that our reference angle is not going to change here. So this 38.68, all right, it is also this angle that goes right there. All right, so what we would do to find this entire angle all the way around would be we would take the 180 minus the 38.68. All right, once we do that, we get an answer of 141.32. All right, and there would be our degree measurement for both of those. But just like most of you do many times while you're doing your homework or on a test, I didn't read the directions very well. It says solve each equation to the nearest tenth. I have the right answer for both of these, but neither one of them are right. Okay? Instead, it's not going to be 38.68. It is going to be 38.7 degrees. And then down here, it would not be 141.32, it would be 141.3 degrees. And then we're good to go. There's our two angle measurements that solve this problem. All right, one more to go, and this is where we use this stuff a lot, is to solve different types of problems like this. Okay, what I would tell you to do is draw a picture. It doesn't have to be a great picture. This is going to be a very boring picture. All right, but we've got a 20-foot ladder that's leaning up against the side of a barn. So we are going to assume that the barn is straight up and down. We're also going to assume that the ground is flat. We've got this 20-foot ladder leaning up against the side of a barn. Okay, there's our picture. That's all you got to do. Now we just got to label it up. A 20-foot ladder, that means here's our ladder leaning up against that. Here's our 20 feet. The top of the ladder is 16.5 feet above the ground. What that means is that's going to be this right here. So there's our 16.5 above the ground. Okay, find the angle the ladder makes with the ground to the nearest degree. What angle are we trying to find? The one that's dealing with the ground. So we're trying to find x here. All right, so if we start with x, we are given an opposite side and a hypotenuse, which means opposite and hypotenuse would be dealing with sine. So we've got sine x equals 16.5 divided by 20. All right, we still got to get x by itself, so we would do sine inverse to get it over to the other side of that 16.5 divided by 20. And then you just throw that in the calculator. Sine inverse, 16.5 divided by 20. gives us an angle of 55.588. All right, that would solve for x. Do we have any extra restrictions on this? It says find the angle the ladder makes with the ground to the nearest degree. So it's not going to be 55.588. It's going to be 56 degrees. And there is our answer for this one. All right, this one takes a lot of work. You need to get going on this right away. All right, don't be afraid to ask questions. Find somebody, whether it's somebody in class, in the other class. Kids in pre-calc and calc know this stuff very well. Or you can ask one of the other, especially the other math teachers. Mr. Triplett even knows this stuff. He does this stuff a lot. So you could ask any one of them by the time that I get back.